All right, we're back. We are on page 5 of note 17 of Calc AB. We're basically just doing a lot of calculus at this point. All of it kind of keyed off of some accumulation functions using the second fundamental theorem, but just really doing calculus, that's when it feels good. It's when you know enough to just like dive in and do some problems. You don't have to keep like, oh, new concept, new concept. No, you want to like synthesize and integrate and like really get a feel for how to use this stuff as you go along, because it really builds up if you're not doing that. So let's see if we can do this. Function g is defined by, so this is the weirdest one we've seen yet, I think I'm comfortable going on record with this. It's, there is an accumulation function in there, but there's also 3x minus 1/4 x squared sitting on the outside. I mean, it's just there. There's nothing we can do about it. So f of x is shown below. The variable doesn't matter. That could be the graph of f of u, f of r, f of t, f of q, f of, I could keep listing everything. So it doesn't matter what the variable is. That's the graph of f, which is usually actually how it's written. Usually there won't be anything here. It'll just say the graph of f is shown below. So don't freak out about that. So let's see what we can do. Write the equation of the line tangent to g of x at x equals 0. So first of all, I need to find g of 0. So I wish I could do that in a place where I could like show it and see the equation. So I'm going to do the work up here and then maybe move it. So I'm going to do some work up here. I need to find g of 0, which is 3 times 0. Like, I don't have to write that part. I'm writing it to show you that I thought about that part of the equation. Then minus 1/4 0 squared plus 2 to 0. So just like straight write it. And I know that you're as concerned as I am that the upper bound is smaller than the lower bound. We're going to flip that. But let's first do this. G of 0 is, all right, so 0 minus 0, and now let's flip it, minus 0 to 2 of f of t dt. Because you always want to go from left to right, then everything works the way you want it to. So g of 0 is going to be the negative of, all right, the integral from 0 to 2. Let's see. So 0 to 2 is going to be, so I'm going to like highlight, and I might end up having to erase depending on what happens. So this region, which I wish I was doing a better job of coloring in, that region has an area of -2. And then this other region here, or actually, well, yes, this region here, that's not a highlighter. Here has an area of +1/2. So overall, I'm getting, I'd rather write that in black, I think. 1/2. Okay, so overall I'm getting -3/2. So the other thing I could have done is I could have realized right away that this region and this region we're going to cancel out, and then you just find the area from 0 to 1. It doesn't matter. You would have gotten -3/2 doing that also. It's a little easier, but you know, no biggie. So this is 3/2. All right, now we need the derivative. So g prime of x is, what is the, so we're finding the derivative of this whole thing here. The derivative of 3x is 3. The derivative of -1/4 x squared is -1/2 x squared. Nope, -1/2 x, not squared. And then the derivative of the integral from 2 to x, that's an accumulation function. Second fundamental theorem, it's going to be f of t with the upper bound plugged in, which is f of x. So plus f of x, and then times the derivative of the upper bound, but that's just times 1. So I'll write it just not to forget it, but we don't really need it. So then g prime of 0 is 3. I'm not going to write the -0, so plus f of 0. F of 0, you go to the graph, and you can see it's -2. So g prime of 0 is 3 minus 2, which is 1. All right. So now the equation, so all of that work really should be for A, and I labeled it as such. Maybe I'll highlight it in like something. This and this. So this is all of our work for that. So the tangent line, though, is going to be y minus 3/2, because that's what we got, is equal to 1, which was the slope, and x minus 0. That's our tangent line. That's the answer to the tangent line. So B is essentially the same question. So I'm going to do the work, I guess, on the other side, right? So everything is at 3 now. So I need to find first g of 3. So this is for b. Definitely, I don't think I left enough space. You know, I'm really suffering that now that I'm like going through and actually doing the notes. Usually in class, everyone just complains at me, and I'm like, yeah, just squeeze it in, get yourself an infinitely large whiteboard, which is what I usually have to work with, basically. But now I really have to like cram it in. It's not great. So 3 times 3, 9 minus 1/4 of 9 plus integral from 2 to 3 of f of t dt. Okay, so what is that? Well, 36, so 27 over 4, and then plus the integral from 2 to 3 of f of t dt. So we go to this, and we need the integral from 2 to 3, which conveniently we already found. It's actually, it's this triangle, which is just 1/2. So that'll be 1/2. So 27 over 4 plus 1/2, which is 2 over 4, so 29 over 4. That's g of 3. All right, what else do we need? We need g prime, right? So we need the point and we need the slope. The slope will be g prime. G prime of x. So I'm gonna like do it again. So the derivative of 3x is 3, of negative 1/4 x squared is negative 1/2 x. Got it right this time. And then plus second fundamental theorem, f of t with the upper bound plugged in is f of x times the derivative of the upper bound, which is 1. So g prime of 3 is 3 minus 3/2 plus f of 3. I like to write out a lot more than, in my experience, almost anybody likes to write, but definitely more than students like to write. But, you know, just do it. Don't get things wrong because you're trying to, like, do them fast. 6/2 minus 3/2 is 3/2. So 3/2 plus f of 3. If you go up here, you can see f of 3 is 1. So plus 1 is 5/2. So our tangent line is kind of crashed. Hopefully not fatally. Okay, so our tangent line, the ordered pair is 3, 29/4. So it's going to be y minus 29/4 is equal to, our slope is 5/2, and then the quantity x minus 3. So let's color code that. Let's say that that is, it's red, I guess. So that, and here's our work for that. All right, so we've done a lot so far. Let's see what the next question is, and if it's feasible and reasonable to actually do it here. Determine the behavior at x equals 1. All right, so when a question says that, it's like increasing, decreasing, concave up, concave down. It could also be like relative maximum, relative minimum. Like there's all kinds of options. So we need to figure out g prime and g double prime. So g prime, we've done twice. G prime of x is, I'm just copying, 3 minus 1/2 x plus f of x. So that means that g prime of 1 will be 3 minus 1/2 plus f of 1. And then f of 1 is negative 1, you can see on the graph. So it's 3 minus, well, it's 3 minus 1/2 minus 1. So 3 minus 3/2 is 6/2 minus 3/2 is 3/2, 1.5. It's actually easier to use decimals on that. Now I need g double prime. So I'm going to move this up a tiny bit so I can fit g double prime underneath it, I think. So we'll move this up here. All right, let's do g double prime. So g double prime, that's the lasso tool. I wish you could see when I do that so that like the thing I say makes sense, but so be it. So the derivative of 3 is 0, the derivative of negative 1/2 x is negative 1/2, and the derivative of f is f prime. Okay, so that means that g double prime of 1 is negative 1/2 plus f prime of 1. Well, now we need f prime of 1. So this is the graph of f, which means that f prime of 1 is the slope of this graph at x equals 1. If you look at the curve, or the graph, at x equals 1, it's this line. And that line has a slope of positive 1, which means f prime of 1 is 1. So this will be negative 1/2 plus 1, which is 1/2. Okay, so we're moving again because I'm spacing this out terribly. Let's go over here. All right, so I really should have, I didn't look, I thought there was more to this question. I should have broken this up into 2 parts. I apologize, this is probably really long. So I'm gonna say, since g prime of 1 is greater than 0, and g double prime of 1 is greater than 0, g of x is increasing and concave up at x equals 1. Okay, so that's my answer. I had to do all that work to get it because you really need to be like clear in what you're doing. So let's see about this next one. Determine any points on the graph of g of x at which the tangent line is horizontal. So horizontal is a word that I look at and I immediately think if the tangent line is horizontal, then I know that the derivative, so this is just telling me that g prime of x will equal 0. So that's what I need to be true. I need g prime to equal 0. So what is g prime? So let's copy that down. So g prime of x, let's make this bigger so my handwriting looks better, is 3 minus 1. It'd be a tragedy if we got that wrong because we've used it like 1,000 times. All right, so now I need g prime of x to equal 0. Don't get intimidated by this problem. It like looks harder than it is. We need this to be 0. But like there's 3 minus 1/2 x and there's an f of x. How are we ever going to solve this? We're going to do it basically graphically. So think about what this means. I'm going to leave f of x on this side. So therefore, I need to know when f of x is equal to add the 1/2 x, subtract the 3. If I can figure out when f of x, the graph above, intersects the line 1/2 x minus 3, each of those values of x will be a place where g prime is equal to 0. So that's what we're going to do. We're going to go back up. So here, let me put a note. We're going to graph y equals 1/2 x minus 3. Anywhere these intersect is going to give us one of the solutions. So what's annoying is that 1/2 x minus 3 doesn't really fit. So 1/2 x minus 3. So minus 3 would be like down here. If I go up 1, I go over 2, which means this point will work. And if I go up 1 over 2, this will work. 1 and 2, 1 and 2, 1 and 2. I don't really need all these, but you know, you get in a rhythm, you go for it. So this, I think, well, it's not going to be tilted correctly at all. Let me try again. One more shot, right? Let's try going this way. At least this way I can like tilt it at the end. Okay, that's our graph of 1/2 x minus 3. So when x is equal to 4, we half of 4 is 2, minus 3 is -1. So that's the correct line. Now the places that I'm looking for are the intersections. So the intersections of this are here and here. If I can find those intersection points, those will be the places where g prime equals 0. So to do that, what I'm going to do is I will actually write the equations of the segments here. So this part, right, so is going to be, this y value is 1, so I'm going to say 1. If I go down 1, I go over 2, so minus 1/2, and then x minus 5. Okay, so if I can find the intersection of that with 1/2 x minus 3, that's one place. So 1 minus 1/2 quantity x minus 5. 1, so this becomes 1 minus 1/2 quantity x minus 5 equals 1/2 x minus 3. And I need to solve that. Let's see, let me get the other one too while I'm like thinking about it, right? So for this, I'm going to say that this y coordinate is -1. If I go over 1, I go up 5. Is that true? Yeah. So plus 5. And then the quantity x minus 9. -1 plus 5 times the quantity x minus 9. -1. Negative 1 plus the quantity, nope, 5 times the quantity x minus 9 equals 1/2 x minus 3. The solutions to these are going to be where g prime equals 0. That's where we have a horizontal tangent line. So let's see if we can actually solve this. I'm going to multiply through by 2 and get minus x plus 5 plus x minus 6. So I multiplied through by 2, so it's like 2. Then I had to distribute a negative 1, and then 2, and then, yeah. So I think that's good. So here I get 2x. This is 7, and then I'm adding 6, so 13. So x is 13 over 2. That, I believe, is one of the answers. And we can actually go back and look, because that one should, that's 6.5. That looks definitely right. Does the other one look like something we could guess? I don't know, maybe 9.5. Probably not, though, because those slopes don't look like they work out that well. But like around 9.5 is what I'm expecting. Here, should I multiply by 2? I don't know. Negative 1 plus 5x minus 45 is 1/2 x minus 3. I don't know. Add 46 to both sides gives me 43. And then if I subtract, so that's, what is that? That's 10 minus 1 is 9/2 x. So x is, okay, 86 over 9. So 86 over 9. Well, 81 over 9 would be 9. And then you have another 5. It's basically what I was expecting. I was expecting like 9.5. So determine any points on the graph of G. You know what? We're not going to do that. We're going to find, determine the x coordinates. Let's squeeze this in. We're modifying the question, because no one in the right mind is actually doing that part. I bet I do this in class too. The x coordinates of any points on the graph of g of x. So we have done that. We needed these values. Those are the values. Anytime x is equal to 13/2, that means that f of x will be equal, wrong color here. So I know this is a long video, but we might as well do it right at the end. If x is 13/2, that means that f of x will intersect this. If that happens, that means that this will equal 0, which means that g prime equals 0. That's what we were looking for. If we do the other one, anytime x is this, it will mean that f of x has intersected this. If f of x intersects this, it means this is true, which means this is true. So those are the x coordinates where the tangent line is horizontal. It's not an easy question, but the concept of adding a line, so this is worthy of special mention. The concept of adding a line to your graph is so useful. We're going to use that a lot. Probably use it in the next problem. I don't really know. But anyway, I'm definitely going to end this here. I'll be back in the next video to do a little bit more, and I hope to see you there. So I hope you're finding this helpful.